Sorry, I forgot you had some blank example pages in your packet. So example 1 was already done for you, and it said determine the fundamental frequency in the first 3 overtones for a 26 centimeter long pipe at a speed of sound 343 meters per second. So you're just finding F1 in both the closed tube and the open tube, and then the first 3 overtones for the closed tube will be 3 times F1, 5 times F1, and 7 times F1. And for the open tube, it'll be 2 times F1, 3 times F1, and 4 times F1. So that one I think was already done for you in your packet. But example 2 and 3 were not. So example 2 says, a vibrating tuning fork is held near the mouth of a long glass tube that's partially submerged in water. If it's partially submerged in water, then it means it's a closed tube. It's open at one end, closed at the other. So that's a closed tube. Okay? And so then it says the tube is raised and the first loud sound, the first resonant point is heard. So we know from what we just finished doing that the first resonance looks like this. It has a quarter of a wavelength in the closed tube. So this is L. And in the question, it tells us that L is 12 centimeters. Okay? What is the wavelength of the sound produced by the tuning fork? Well, if we look at this, this is a quarter wavelength. So L is equal to 1/4 lambda, which means lambda is equal to 4 times L. And in the question, it tells us L is 12 centimeters. So L is equal to 4 times, changing it to meters, 0.12 meters. So lambda is equal to 0.48 meters. That's all they were asking for in Part A. What is the wavelength of the sound produced by the tuning fork? Part B says, what would be the length of the air column needed in order to hear the second and third resonating point? So now, you're going to continue to raise the air column out of the water. So the length is going to change, and you're going to keep raising it until you hear the second resonating point. The second resonating point, we know from the pictures we just did a few minutes ago, is going to look like this. It's going to be an antinode at one end, a node at the other. This is the new L, and it's equal to 3/4 lambda. Okay? Well, how do 3/4 lambda? So, well, we just found lambda, so we can just fill that in here to get the new L. 3/4 times 0.48